The overwhelming majority of design systems that are built today are built for the web. And while that's great news for web developers, what happens if you want the components of your design system to be used on other platforms, like mobile, for example? Well, today we are going to venture into the world of cross-platform design systems and take a look at how we can build a stencil component that can be run on both the web and mobile devices. To do that, we're going to be using Capacitor, Ionic's native runtime. And Capacitor is going to give us access to all of the native device features and allow us to run our web components on mobile devices. Today we're going to be building an avatar component that will allow the user to change their avatar by pulling in a photo from the file system, as well as using the device camera to take a new picture. So if that sounds interesting, stick around and we'll jump right on into it. Alright, so to get started, I've just got a standard stencil project set up here with this one My Avatar component created. It's just a blank component right now, but this is where we're going to be building our avatar component. Now, before we go ahead and do that, there's a few things that we need to install first to add Capacitor to our project. So first we'll install the Capacitor core with npm install @capacitor/core, and then we'll install the Capacitor CLI as a dev dependency. Now, with those two installed, we can initialize our project with npx cap init. This will prompt us for the app name. I'll just use the default avatar component here. Then it will also ask us for a package ID, and this will be unique to you or your company. Since this is just a tutorial and I won't be publishing this, I'm going to use the example given here. So the next part of the setup process is going to be installing packages for the different platforms that we want to support. So that could be iOS or Android or even both. Now, today I'm just going to be demoing for iOS, but the process for Android is practically identical, and I'll leave a link down below with detailed instructions on how you can set that up. So for iOS support, we'll need to install @capacitor/iOS. Then we can add the platform by running npx cap add iOS. That's all we need to install for now, so let's turn back to our stencil component and start building that out. Now, the first thing we'll need to do is add a prop to our component for the image we want to display. I'll call the prop image and also give it a default value in case one isn't provided, maybe in the case of a new user who doesn't have an avatar yet. I'm also going to provide the mutable true option because we're going to be changing the value of this image when the user changes their avatar. Oh, and don't forget to import prop at the top there. Great. Next, we need to actually display that image by adding an image tag to our template and setting the source to the value of the image prop. I'm also going to add some CSS here just to style that image a bit and make it look a bit more like an avatar component. At this point now, we're ready to install the Capacitor camera plugin, which is going to give us access to the device camera as well as the photo library, and we'll see in just a bit how we can make use of that. But for now, we're going to jump on into the terminal here and install the Capacitor camera plugin with npm install @capacitor/camera. We'll also now build our project for the first time and run npx cap sync, which will sync our app with the native platform project, in our case, iOS. Now, before we can start actually using the camera plugin, we have to add some permissions. So for iOS, we have to add some usage descriptions to our info.plist file. I'll make sure to leave a link down below for more details on configuring these permissions. With that out of the way now, we can turn back to our avatar component and import the camera and camera result type at the top. And now we can define a handle click function that will use the camera plugin to get a photo from the user. So when this function runs, it will prompt the user to provide a photo from their photo gallery or to take a picture with the device's camera. We pass a few options to help define the value we get back, and then we set the component's image to the photo that's returned. And this web path is just a path that can be used for the source attribute of an image. So with that function defined, we can now attach it to the onClick of our image element. Let's go ahead now and see how our component works. I'll jump into our index.html file and add my avatar to the body. Then we can run npm run start and we'll see our component in the browser. Now, what's great here is that the capacitor camera plugin actually recognizes that we're on a browser and prompts us to provide a photo from the file system. So our component works great in the browser. Let's go ahead now and see how it works on a mobile device by running npx cap open iOS. Now, this command will open up our app in Xcode. At the top here, we can select what kind of device we want to run on and hit this play button to run our app. And here's our component running on an iPhone. We're bleeding into the top bar a bit here because we didn't add any padding or margin, but other than that, it looks really great. So now if we click on the image, the capacitor camera plugin will use the native features to prompt us to select a photo or to take a new photo with the camera. And when we select a photo, it gets updated in our component. Now, our component is great as it is, and we could stop here if we wanted to, but I'm going to add one more thing just to improve the component API a little bit. What I want to do is add a custom event that will fire off when the avatar image is changed. So that way consumers of our component can listen for this event and do something in reaction to the image being changed. So to create a custom event, we're going to use the event decorator, and I'm going to call the event myChange. It'll be of type event emitter. Of course, now we'll have to import these at the top. Now at the end of our handle click function, we can emit this event to let the consumer know that the image has been changed. So in practice on the consumer side, this now means that we can add an event listener for myChange and then execute whatever code we want when the event occurs. For demonstration's sake, I'll just add a console log here, and now if we run our component again, we'll see that when we change the avatar image, that console log runs. And there we have it. In less than 50 lines of code, we've built our very own cross-platform avatar component. Now, I wanted to build this component to showcase how you can incorporate Capacitor into your Stencil projects and start to see how you can build one design system that supports multiple platforms. So if you found this interesting, go on and check out the Capacitor docs and see everything that Capacitor is capable of. Also, feel free to let me know down in the comments if you want to see me build more complex Capacitor and Stencil components. As always, I'll leave a link down in the description to the GitHub repo with all of this code, as well as a link to a blog post that I've written on this topic. Thanks so much for watching, and I'll catch you in the next one.